The rest of this section deals with change of basis. So what I want to look at is this is the same example we had at the beginning, but I changed the basis here, the S basis. And these are the coordinates of the three different vectors there with respect to the basis t, which is the same as before. Let's also work out what the coordinates are with respect to S. So if you look at S, it's almost the standard basis except for it's 2, 2. It's a 2, 0, 0, 2 instead of ones there. So, this is going to be something that goes over 2 units, like that. And this is a vector that sticks up 2 units. So for instance, if we wanted to get to V3, we'd have to use 2 of these purple vectors, but then only half of one of the blue ones. So the coordinates with respect to S of this would be, let's see, 2 of these and a half of the other. Now if we want to find V1, we would have to use -1 of the purples. Let's see, purple is first. So we'd have -1, and then we would need 2 of the blues to go up here and then here. Nice multicolor vector there. Let's do the last one. Whoops. All right, to get V2. To get V2, we would go, let's see, 2.5 of these guys. And then how far up do we go? We have to go up 1, 2.5 of those. And one thing you might notice right off, if you just look at the regular old coordinates of these points, this one up here, V2 is 5, 5, and these coordinates are exactly half of that. And it's because we've got the 2's here in place of where we would have a 1 if it were the standard basis. And same thing going on over here with V3. This would normally be the point 4, 1, and this winds up giving us 2 half. And over here this would be what? -2, 4. But using this basis, it winds up, instead of being -2, 4, it's -1, 2. So it's exactly half. So the thing is, it would be nice to be able to convert straight from one basis to another. And we're going to do that using transition matrices. But before we do that, let me say, this might seem kind of silly or arbitrary, but it's actually kind of important. Sometimes, well, when you take differential equations or some other courses, you're going to see situations where you'll have different bases, and it's important to be able to switch between them. And even with this stuff, I mean, my example was kind of silly, but if you think of this as a crane being here at the origin, and it always points up at an angle of 45 degrees, and it can go, let's say it could be extended however far, and then it could drop a line straight down. That could tell you how to get to this point right here by sending the boom up and then dropping the hook down. So it's kind of a silly example, but it gets the point across. Okay, let's look at how to convert between bases. What you do is you find what's called the transition matrix, and once you've got the transition matrix, you can do just matrix multiplication to translate from one basis to another. So let's look at how to build that. Suppose you're given two ordered bases, B and C, and the basis vectors in there are called little b and little c. I forgot to make those look like vectors, but it's okay. So here's how you do it. To get the transition matrix that goes from B to C, you put B over here, you put those vectors over here as columns, you put all the C vectors as columns over here, and it's probably worth writing here. This is B to C, so we're going from here to here. So I'm just going to write that on the side there because that's how I keep track of which ones to put in there. But the idea is you form that matrix and then you row reduce it. Since this over here is a basis, it's going to have to row reduce to give you an identity. And then this matrix over here, which I'm calling P, that's the transition matrix that converts from XB to XC by simple matrix multiplication. And some books, and I like this notation, you can call it P with a subscript of B back to C. So that tells you that it's the transition matrix that converts from B to C. And the reason that it's done that way with the backward arrow is so that you that also helps keep track of how to set this up here. You've got B on this side and converts to C. Okay, so let's find the T to S transition matrix for this. This is that's the basis we had, the two bases we had above. So to do that, we would just, let's see, we're doing T to S. So that's T to S because of from to. So our S vectors are going to go over here. And our T vectors are going to go here. And then we row reduce this. Now, we could put this into octave, but this is really easy to row reduce. You just take half of the top and half of the bottom. So half of the top row gives us this. Half of the bottom row gives us this. And so that's our matrix that converts from T to S. Like that. Okay, and here's how you use it. This next example says use the matrix from the previous example to convert between VS and VT for some of the points up there. Let's see, this is T to S. So what we'll do, let's go back up here and pick one of these particular points. Let's pick V3. V3, I'm going to just copy this. And down here, I'm going to paste it in. Paste it in as an image so I can make it kind of small. Let's see, that's T first. This one is V3 with respect to T. And this one is V3 with respect to S. So what this says is if we take this, now this is the thing that converts T to S. So we're going to come over here and take the T matrix, 4, 3. And when we just multiply this out, this should give us the S matrix, 2, 1/2. So let's see, what do we get here? We get 4 times a half, or let me do the order differently. We get a half times 4, plus 0 times 3. Then on the bottom we get a half times 4, minus a half times 3. So sure enough, on the top that gives us 2 plus 0 is 2. And on the bottom it gives us 2 minus 3/2. So 2 minus 3/2 is 1/2. Sure enough, it converts for us directly there. I want to do one more of these. Let's get the T coordinates, the coordinates with respect to T of V2. Let's see, it's 5, 0. If we take that and multiply it out, you get half of 5 and then half of 5 again. So that'll convert from T to S. All right. If you want to convert backward from S to T, there are two ways you could come up with the S to T matrix. You could either go back up here and set this up and swap these, or you can just take the inverse. So the T to S transition matrix, T to S and S to T are inverses of each other. So if I wanted to find the other one here, let's see, we had P T to S, let's do P S to T. If we wanted to come up with that, we just have to take its inverse. Let's do that right quick with Octave, and then I think we'll be done with this video. Let's see. So our matrix, let's call it P because that's what I called it earlier. It's 1/2, 0, 1/2, -1/2. Then we just take the inverse of P, and it gives us that. So this is going to be 2, 0, 2, -2. All right, so we'll play around with this stuff some more in the next video.